Hello everyone, this is Esther here. Welcome to my channel. Today we're going to be seeing the fourth question of exercise 15.1. So let's get started. In this question, we see that three coins are tossed simultaneously 200 times with the following frequency of different outcomes. So we have outcome for 3 heads as the frequency is 23. For 2 heads it is 72. 1 head 77. No head 28. If the 3 coins are simultaneously tossed again, compute the probability of 2 heads coming up. So in simple words, we need to find out the probability of 2 heads. So this is very simple. That will be the number of times 2 heads come up by total number of frequencies or total number of trials, anything you can say, okay, or a total number of frequencies. So this will be equal to number of times 2 heads come up will be 72 by total number of trials of frequency is what, 200 times. So divided by 200. Simplify this, you will get 9 by 25. So this will be a final answer, or you can even go for the decimal format of 9 by 25. That is also fine. This is the fourth question. Let's move on to the fifth question. So the fifth question is, an organization selected 2,400 families at random and surveyed them to determine a relationship between income level and the number of vehicles in a family. The information, sorry, they should be separate. The information gathered is listed in the table below. So basically 2,400 families at a random level were selected, and they have made a relationship, or they made a table where their monthly income and the vehicles that they have are shown. Okay, so they're just relating these two things, the monthly income and the vehicles per family. Okay, now we are going to be seeing the information here. So for example, if we have families that earn less than 7,000 per month, and the number of vehicles that they possess are also given here. So a family that earns less than 7,000 and has 0 vehicles is 10 families. So less than 7,000 and have 1 vehicle is 160 families. Less than 7,000 and have 2 vehicles is 25 families, and less than 7,000 and they have more than 2 vehicles, they are 0 families. Okay, so like this every other data in the table also has been given. Okay, so basically this is the income side and this is the families, and these are the number of families accordingly. Number of families accordingly. Okay, now, so now in the question we say that suppose a family is chosen, okay, at random. Find the probability that the family chosen is earning rupees 10,000 to 13,000 per month and owning exactly 2 vehicles. So how will we do this? So basically earning rupees 10,000 to 13,000 per month, meaning in this category, hold on 1 second, let me just erase it, so keep it too shabby. Okay, now according to the question we have rupees 10,000 to 13,000 per month families earning, and they're owning exactly 2 vehicles, so that will be 29 families. Okay, we need to find the probability of that. So probability of whatever is written here, you can just write that in the bracket. For now I'm just going to write probability for event 1, meaning according to the question whatever is given for now, but you guys have to write that in the bracket. So this is equal to again you need to write that here number of families earning 10,000 to 30,000 10,000 to 30,000 and has two vehicles, so by the total number of families. Okay, by the total number of families. So this will be 29 by the total number of families is 2400. Okay, or you can even say, instead of writing this top part, instead of writing this top part, instead of this you can also say that number of families in this category by the total number of families. You can say like that. That is much more better, because you're saying that it is a very long statement to write here in the numerator according to the question. So instead of that, you can write number of families in this category. Also here we have, for event 1 I've written, instead of this you can also write this too. Okay, now 29 by 2400 will be your simplest form. You can convert to decimal if you like. Now for the second part, we have earning rupees 60,000 or more per month and owning exactly one vehicle. So 16,000 or more per month and owning exactly one vehicle, which will be 57952400. Okay, so probability of families in this category by, which is equal to again number of families in this category by the total number of families. Okay, this will be equal to what? Number of families in this category will be 579 by total number of families is what? 2400. Again, this is the simplest form. Okay, now moving on to the next part, that is the third part of this question. So probability of families who are earning less than 7,000 per month and does not own any vehicle. Less than 7,000 and owning no vehicle means 0. So that will be 10 families. So same thing what I wrote above, you can just write that again. And here also same thing, number of families in this category by total number of families. So this will be what? 10 by 2400. So 1010 1 by 240. You can convert to decimal if you like to. Now moving on to the fourth part. So for the fourth part, here we are seeing earning rupees 13,000 to 16,000 per month and owning more than two vehicles. 13,000 to 16,000 per month and owning more than two vehicles, meaning above two. So here this will be 25. So same thing here, you write whatever we wrote before. This is equal to so and so, and you will get 25 by 2400. Okay, now when you simplify this, you will get 1 by 96. Okay, so you can go first by 5 table and then 4 table, sorry, not 4 table, sorry, what am I saying, first 5 table 25 and you will get 5, then 2400 will get 480, then again 1, and then you can go for 9, then you will get 6, right? So this is how you get 1 by 96. Now last part of this question is owning not more than one vehicle. Not more than one vehicle means they're not specifying the income category. Generally speaking, calculate the number of families that calculate the probability of number of families who do not own more than one vehicle. Now such questions are very tricky, I understand that too. but you need to understand what is the question trying to say. Owning not more than one vehicle means what? One vehicle and beneath that, right? So that means minimum is 0, maximum is 1. Owning not more than one vehicle. So this will be, can you see this thing? No, right? Okay, wait one second. So the fifth part is owning not more than one vehicle. Probability of not owning more than one vehicle. So this will be what? Probabilities of, let's say, okay, let's say this is 1 and this is 2. Okay, so that means this will be total number of families who fall under 1 and 2. What is 1 and 2? This whole section, this is 1 and this is 2, I'm saying. So basically, not owning more than one vehicle means the number of families who have no vehicles and the number of families having one vehicle. That means minimum is 0, maximum is 1. Okay, so all the families that fall under having no vehicles and one vehicle will be in the numerator by divided by the total number of families. So this will be what? First of all, we will add all of these things. So when we add all of that under the number 1 category, we will get that is 0 vehicles, right? So we'll get 10 plus 0 plus 1 plus 2 plus 1 plus the families who fall under the second number, that is the 1 vehicle. Okay, so that will be 160 plus 305 plus 535 plus 469 plus 579. So basically we are adding all the families that lie under the category of possessing 0 vehicles and 1 vehicle. Okay, by total number of families will be what? That is 2400. You add all of this up, you will get 2062 by 2400. Okay, so this, when you simplify, you'll get 1031 by 1200. This will be your simplest form. Clear? I hope you understood how to do this question. So if you have any doubts, let me know in the comment section down below. And now let's